Like with all questions, worded questions, it's so important that you read the question carefully. Practice highlighting key components of the question and starting a solution by writing down what you've identified from the question. So let's put that into practice. It says, a circle has a radius of 5 centimetres. Just for now, I'll just underline radius. I'm sure it's going to be important. 5 centimetres. Find the length. I think it's always really important to identify what the question wants you to find. So you would be reading each question looking for the find or what is or how many, those sorts of words. Find the length, and we know that to be L is the length of the arc of this circle that subtends. Now subtends just means is created by, is supported by an angle of pi on 3 at the centre. So that we know is going to become our theta. So like I said, in our solution we should always begin by identifying what we have been given in the question. Circle radius 5. R is equal to 5 centimetres. The physical writing of information like that enhances the connection to the thought process in the brain. Physically writing it with your hand, connected closely to what's going on with your thought processes. So keep that in mind and practice it and put it into the way that you start your solution, because it's only going to help. We're going to find L. Now again, by actually writing that L, hopefully you will make the connection to this formula, whether it be because you've learnt it, it's on the reference sheet, whatever. You'll make this connection. The length of the arc that subtends an angle, like I said, that's our theta, and it's pi on 3. Clearly, there's no unit on that, which means it is in radians. In radians. Great, happy about that. Because for me then to use the formula, L equals R theta, I don't have to make any adjustment. Therefore, L is equal to the radius was 5. Theta is pi on 3, which gives us L is 5 pi on 3 units, which are centimetres. Moving on to the second example, we're going to go through a similar process, read the question carefully, identifying the information that's given, and then actually writing that as the beginning of our solution. So express the length. Express the length. It's almost like find the length of the arc. In terms of in terms of pi, given it subtends a right angle. Subtends a right angle. What does that mean at the centre? That is our theta at the centre, and it has a radius of 150. Like I said, I'm going to actually write this information down. Express the length of the arc. I'll say that is the same as find arc length. That's find L. And again, hopefully you're making the connection as you write that to the formula. L is equal to R theta, provided theta is in terms of radians. Say these things to yourself. Say them. Then they will become things you will automatically recall as you're doing a question. Given it subtends, this arc subtends a right angle, so we know that theta is equal to a right angle. What's a right angle in terms of radians? it is pi on 2. Where the radius is 150 centimetres. Nice, it's the radius. Therefore, I've made the connection to the formula L equals r theta. L then is equal to 150 times pi on 2, so L is equal to 75 pi. And I've satisfied what it said in terms of pi. That means I don't go to my formula, and here I've got the answer, so I know I'm correct. Example 3 is it's quite different, and again, we'll have to read it very carefully, identify the information that's given, and then begin our solution by writing down what we know from the question. Now, it says a circle has a chord of 25 millimetres. So a chord, I really have to underline that and register that this is a chord. Haven't had a question with a chord in it before. Hopefully your understanding of circles covers the concept of a chord, and a chord is a straight line joining 2 points on the circumference. And we know that that chord is 25 millimetres long. Now, like I said, this question is quite different because we haven't had anything to do with a chord in our formulas, especially the formula for calculating arc length. Let's continue on, see what else it's giving us. With an angle of pi on 6 subtended at the centre, pi on 6 at the centre. So that's familiar, yes, what's given angles at the centre. So this one here, and it's nice that it's given in radians, pi on 6, says find to 1 decimal place the length of the arc. Right, so that again is something we're familiar with. The length of the arc that is cut off by the chord is L. So I have to find L, and like I said, that's quite familiar. So let's, apart from the fact that I've got it on a diagram, let's begin our solution writing this in a more mathematical way. So our chord is equal to 25 millimetres. Again, I'm thinking chords don't come into calculation of arc length. Our theta is pi on 6, and that's great because it's in radians. I'm going to find L, cut off by the chord. Now, L, the connection I'm making is that L is equal to r theta. When I look at that, I realise I don't have r. I don't have r. I do have theta, but I don't have r. Now, what I can see from the diagram is that r is part of a triangle, where this side is 25 millimetres, and this angle is 30 degrees, or pi on 6. That was 30 degrees. What do I know? I know this is an isosceles triangle because all radii are equal in length. Those two sides are equal. Means these two angles are equal. So we've got 180 minus, what was that, 30, which is 150, and divide that by 2. These are both 75, but I'm back to degrees. I'm really mixing things up now. So I've got some degrees, I've got some radians, and I need to find r. So what am I ruling out? I'm ruling out Pythagoras because I don't have a right angle triangle. Is there any way I could use the sine rule, maybe, because we've got a side opposite an angle and a side opposite an angle, or we've got a side opposite an angle. In that case, I think I'll go back to calling this actually 30 degrees. So, using the sine rule, which is A on sine A is B on sine B. Now, this is a good example of a question where you need to make lots of connections. You need to draw on your resources, and certainly without any indication of what you might need to be drawing on. The only way that you know what to access is through your diagram. So that's so critically important that you have a diagram. I might pause the video and do some calculating and come back and talk about it. So you can see here I've set up the sine rule, and I've gone back to degrees, which is fine with the sine rule. 25 on sine 30 is R on sine 75. Cross multiply R times sine 30, 25 times sine 75, divide by sine 30. Sine 30 is a half. Divide by the half is multiply by 2, which gives me 50 sine 75. I left it in that format. And I've left my calculator in degrees. I'll just pull that up so you can see that. Calculator's still in degrees because, I am finding the sine of 75, which is degrees, using the formula L equals R theta. And I didn't calculate the value of R because I didn't want to introduce error. I used the full title for R in 50 times sine 75 times pi on 6. That does have to be in radians. Did that calculation, rounded to 1 dp, and got 25.3. I'll stop the video there and do the examples for the other calculations in a separate video.